Hello and welcome to Chapter 1, Section 2, Piecewise Functions. Our essential question is, how can you describe a function that is represented by more than one equation? What you're going to learn is how to evaluate piecewise functions and how to graph and write piecewise functions, which include stepwise functions, and then we should be able to also write an absolute value function as a piecewise function. So what is a piecewise function? A piecewise function is a function that is defined by two or more equations, right? So usually we've seen what we've graphed is a function that's just the same. One function works for the whole thing. We do the same thing throughout the whole entire graph. But a piecewise function has two pieces and it applies to a different part of its domain. So here's an example of a piecewise function. F of x equals curly brackets x less than or equal to 0 for the equation x minus 2, and x is greater than 0 for the equation 2x plus 1. Okay, the expression x minus 2 represents the value of f when x is less than 0. Okay, so what we're doing is we're focusing on the x-axis first. Okay, so this is our domain. So notice how on our first part where it's x minus 2, well, the x minus 2 only corresponds to the part left of the 0. So if we do this, okay, so the first function only corresponds to the left side of the graph. So this is because it's only less than 0. So this bottom piece, you see, if we were to extend that piece, it would keep on going as a straight line all the way forever to both directions. But because our domain says less than 0 only, then we only want to do it for those values of x that are less than 0. So everything to the left of 0. And then our second function is when x is greater than 0. So we only want to use the part of the graph that is to the right of 0. All right, so we're going to first start off by evaluating a piecewise function. So I'm going to go ahead and take some time here to write out my piecewise function. And I'm going to break it down into different parts. Okay, so I have x less than or equal to 0. I have a colon. And then I have x minus 2. Then I have a comma. I have x is greater than 0. I have another colon. And then I have a function or an expression 2x plus 1. And then my bracket closes. All right, so there's various parts of this. And basically what this is a piecewise function. The function is divided into two. Okay, our comma here divides our two different parts of our function. So this is one piece, and this is our second piece. Okay, these are our pieces that are divided by the comma. Now within each piece, okay, we have other parts, right? So this is the domain of our first piece of the function, and this is the domain of the second piece of the function. How I like to think about those is those are the rules, okay? And then the second parts are the expressions, okay? So the rule tells us which of the two expressions we have to use, all right? And then I'm going to go over through the first example and show you guys how exactly what I mean by that. All right, so on our first function, we want to find the value of the function f when our value is 0. Okay, so what we're going to be looking for is we're going to be checking to see which piece of the function we have to use to substitute. Okay, so we want to take a look at our domain. Okay, so which one of these rules, which one of these domains does the 0 fall under? Is 0, our x value, less than 0? Or is it less than or equal to 0, or is it greater than 0? Okay, and 0 is indeed less than or equal to 0. So we're going to use our first piece. All right, so because this one works, we're going to use the expression that is next to that rule or that domain. So we're going to use x minus 2. So I'm going to bring that down over here, x minus 2. And instead of the x, I'm going to go ahead and substitute. Let's change everything there. Let's put this as orange. Okay, so we're going to substitute our x for x minus 2. And then all we have to do is subtract here. So we're going to get is equal to negative 2. So our value of our function at 0 is negative 2. So I'm going to go ahead and type that in over here in our function. All right, and then that's pretty much it. That's it right there. Second part, okay, I'm going to show you how the value of our function is going to also work for any other point. So I have my second value that I'm looking for is the value of f when x is equal to 4. Okay, so now we're going to again take a look at the domain. So we're going to take a look at this first part. Okay, which one of those does the 4 fit into? Is 4, our x, less than or equal to 0? No, 4 is not less than 0. It's not equal to 0, so it's not that piece. So is 4 greater than 0? Okay, it looks like it is. 4 is greater than 0, more than 0. So we're going to use the second piece of our function. So we're going to use 2x plus 1. Okay, so we're going to use 2x plus 1. Instead of the x, I am going to substitute my 4. So instead of the x, I'm going to put a 4, and then I'm just going to solve it. I'm going to multiply first. Bring down the 1. And then last step here, add these two, and I get 9. So the value of my function when x is 4 is equal to 9. So f of 4 is equal to 9. Okay, and that is how we evaluate a piecewise function. All right, so now we're going to move into graphing a piecewise function. So graphing a piecewise function works in a similar fashion as how we evaluate it. So what we want to do is we want to take it one piece at a time. We want to graph one piece of the function at a time. Okay, so what I'm going to do here is I'm going to go ahead and write my function. I'm going to divide it. So the first part of my function says when x is less than 0. And then the second part of my function says when x is greater than 0. So my 0 is here. Okay, so I'm going to write one function on the left side, and then the other function will be on the right side of the 0. Okay, that's what that means. So I'm going to go ahead and write those two up at the top. So because x is less than 0 is to the left of the graph, I'm going to write that one out here. And that's the function, the piece of the function that pertains to x is less than 0. And then x is greater than 0 is to the right. So I'm going to go ahead and do this. And then my function is just x. All right, so then what we're going to do is we're going to be graphing this using what we know about graphing functions in slope-intercept form. So remember that slope-intercept form is y equals mx plus b. Okay, and I'm going to go ahead and link a video on how to graph a function in slope-intercept form in the description of this video. All right, so what we do first is we are going to identify, plot our y-intercept. Okay, so first thing is that we're going to plot our y-intercept, okay, which is there at -4. Oh, that's +4. Here at -4. All right, and then we identify that our slope is the number in front of the variable, which is in this case is an invisible 1, so it's -1 over 1. All right, so what I'm going to do here is I'm going to use what I know about slope, down 1 over 1, down 1 over 1. Okay, and I can do the same thing backwards, so I can go up 1, left 1, up 1, left 1. Okay, so I'm going to go ahead and erase all of those, but I'm going to plot all the points. Okay, so I would go there. All right, so it's basically a straight line, and it looks like it's decreasing. All right, so I'm just going to go ahead and connect all of these points. Blue as well. Okay, there we have it. All right, so that is graphing this part. All right, but this stuff over here also has something to do with the graph. Okay, so what it's telling us is that I only want the part of the graph that is less than 0, meaning that I only want the part of the graph that is to the left of the 0. So whatever is to the right of the 0, I don't really want to keep. I don't really want to include. Okay, so what I'm going to do is I'm going to keep the left part of this line, but I'm going to erase everything to the left of the 0, to the right of the 0. So at right there. So I'm erasing this whole part right here to the left, to the right of the y-axis. Okay, so that's how we graph that. And then also the last piece of this is this right here. Okay, less than. Okay, we have 4 different inequalities. We have less than or equal to, greater than or equal to. Okay, so this is also going to be included as part of our graph. So if we have any of these two, at the starting point, at 0, at when x is 0, you're going to draw an open little circle. If it has an equal to sign, or the little line underneath the inequality, you're going to draw a circle that is filled in. Okay, so in this case, we have less than, which is this one here. So that means I'm going to go ahead and draw an open circle at that point. Okay, so I'm going to leave it open, not going to fill it in. All right, and then I am done graphing that first piece of the function. Okay, next up, I'm going to go ahead and graph our second function, which is just x. So what this actually is 1x plus 0. Right? It's not written, but we know that that's how it works. So our y-intercept, that's what we start with first, the 0. So we start with our point there. Then we go with our slope 1 over 1, up 1 over 1, up 1 over 1, or down 1, left 1, okay, and so on. So I'm going to go ahead and plot those points. Boom. All right, and then I'm going to go ahead and draw my line that goes through all the points. There it is. Okay, and then we're going to go ahead and erase. Okay, so we want only the part that is greater than 0. Okay, so we only want the part that's greater than 0. So we want every part of this red line that is to the right of the y-axis. So I'm going to go ahead and erase everything that's to the left. Okay, so I don't want any of that piece anymore. And then the last part is this. So because it has a line underneath the inequality, that means that we want a filled in circle right here where the graph begins at 0. So that one's a filled in circle, okay? And you should always have a filled in circle and an open circle when you are graphing a piecewise function. Example number 3, we are going to be writing a piecewise function. So now we're going to go work in reverse. So we've graphed a function. Now we have to look at this graph and try to write a piecewise function. So write the actual function. So what I'm going to do first is I'm going to type in here. I'm going to type in the basic, what it looks like, what the function looks like. So I'm doing f of x, oops. And then we're going to set that equal to, I'm going to put the curly bracket, which is right down here. If you're typing using the Desmos keyboard, it's right there. Or if you're using your actual keyboard, it should be on top of this little flat bracket. Okay, so we want to use the curly bracket. That's how we know that it's a piecewise function. All right, so what we're going to have is a domain. So we're going to have something x is less than or greater than or less than or equal to. Let's leave it as less than or one of those two. It's going to be greater than or less than. So then we're going to have a colon. How do you do colon? Doesn't let me do colon. Let's change the language. Having some technical, there we go. Let's see if that works. There we go. All right, and then we're gonna have some function. Let's do it this way. We got a domain. Then we have a function, comma, another domain greater than 0, and then the second function. All right, so we know, so what I did here is I actually wrote less than and then greater than, just because I have two pieces of the function, right? This piece and this piece. And one's going to be to the left, which is less than, and one's going to be to the right, which is greater than. So that's why I set that up that way, because I already know it's going to be less than or greater than. So one of these is going to have an open circle. One of them is a closed circle. So the one with a closed circle is the one that is to the left. So that's less than. So I'm going to leave that one without the underline. And the second function has a filled in circle and it looks like it's going to the right. So that's greater than. So I'm going to actually change that to greater than or equal to. So what you do to make that happen is you can type it using this, or you can go ahead and do a greater than symbol and then an equal sign, and it'll do it automatically. All right, so now we got to actually figure out what the functions of these pieces are. All right, so what are the equations? I'm going to color this one in blue so that we know that that's the one we're working on in blue. Okay, so we're going to write a function in the form of y equals mx plus b, so slope-intercept form. All right, b represents our y-intercept, which is this point here. Where does the line cross the y-axis? And it looks like it's crossing it at a positive 3. All right, and then next, we're going to go ahead and figure out the slope of this line. So the slope of the line, okay, I'm going to pick another point on the graph, let's say this one here. And then I'm going to see how long it takes me to get to that one. So I'm going to do rise over run, up 1, 2, 3, over 1, 2, 3. So it looks like it's 3 over 3, which I can simplify to just be 1. So my first function on the left side, or less than 0, is 1x plus 3. Okay. We're going to repeat that process on the right side. So again, we have y equals mx plus b. We start first by identifying our y-intercept, which is b. Where does the line cross the y-axis? It looks like it's at -1. And then we're going to go ahead and pick 2 points on the red line to identify our slope. So I'm going to pick a point, let's say all the way up here, and let's use that point right there. How do we get there? So I'm rising 1, 2, 3, 4, 5, 6. So I have a slope of 6 over 1, 2, 3, 6 over 3. So then I can simplify that to 6 divided by 3 is 2. So then I have 2x minus 1. So that's my second function. So I'm going to erase this here. And I'm going to type 2x minus 1. And that's it. Okay, that is my solution. That is the piecewise function. All right, so this is the end of lesson 1.2. In this lesson, you should have learned how to what piecewise functions are, how they are written, how they are graphed, and a couple other things that we learned in this last slide. If you have any comments, questions, or concerns, please feel free to post them in the comment section down below. Thank you, and I will see you next time.